Hi, today we're going to talk about resistors. Before we really start, I suppose we should start right at the beginning. So a resistor is an electronic component that's used for three main purposes. It's used to either limit the current in a circuit to protect a component or a system. It's used to set a specific current in a circuit, and it's also used to set a specific voltage in a circuit. There are three main uses of a resistor. Today we're going to talk about resistors in parallel, and we need to talk about what parallel actually means. So I've got a little diagram here which I hope you can see, and I've got two resistors here and a power supply, and we've got a ground. So in electrical circuits, the current will flow, in conventional current, will flow from the power supply down to ground, and it will flow through whatever components are in the circuit, in this case two resistors. A circuit that's in parallel is a circuit that provides more than one path to ground for the current. So you just need to remember that. If it's in parallel, there'll be two paths for the current. If there was just one resistor going down to ground, that would be called a series circuit. Now, there are a few rules we need to know about resistors in parallel, and the first one is that no matter how many resistors you have in parallel, the total resistance value of that circuit will always be lower than the value of the smallest resistor. So say for example we have a circuit that has a 100 ohm resistor, a 50 ohm resistor and a 10 ohm resistor, and they're all in parallel. The total resistance of that parallel branch or that parallel bank will be less than the 10 ohm resistor. That's the first rule. The second rule is that the voltage drop, the electrical pressure drop across each resistor in that parallel bank will be the same. So in my example later on, we're going to use a voltage of 15 volts. That 15 volts will be dropped across all of the resistors in the parallel bank. When we go to work out resistance in parallel, there are a couple of ways of doing it, but I'm going to show you the way that I enjoy doing it most, if that's the right word, and that's called product over sum. The main thing you need to remember with product over sum is that it only ever works with two resistors in parallel. So for example, I have three resistors here. I can only use product over sum with two of them, but then I can take that result there and apply product over sum with the third resistor. All of my resistors in this parallel circuit are 10 ohms, just to make it easy. So what we're going to do, we're going to pretend that the third one here that I'm covering up doesn't exist. We'll call it our ghost resistor if you like. And we're just going to deal with these two here, which are 10 ohms. So we take the product of both of those resistors, that's multiplied together, 10 times 10, and we divide it by the sum, 10 plus 10. So 10 times 10 is 100, 10 plus 10 is 20, and you do that sum, you'll end up with 5 ohms. So when you do product over sum with the first two here, the total resistance of both those resistors is 5 ohms. So we can redraw the circuit, and the two resistors can be replaced by a single resistor with a value of 5 ohms. And then we can do product over sum again with our remaining ghost resistor. So when we do that, 5 times 10 over 5 plus 10, we end up with a total circuit resistance of 3.3 ohms. We're just going to introduce a little bit of Ohm's Law now. And Ohm's Law states that the current, the electric current flowing in a circuit, will be equal to the voltage divided by the resistance. Okay, so in our circuit, if we imagined we had a voltage supply of 15 volts and the resistance is 3.3 ohms, the current flowing in that circuit will be 4.5 amps. We divide 3.3 into 15 and we get 4.5. If we go back to one of the rules that we stated earlier, where in any circuit, in any parallel circuit, the voltage across each resistor is exactly the same. So V1 is equal to V2, is equal to V3, is equal to the voltage supply. Then we can work out the current flowing in each of those resistors, because each resistor will have 15 volts flowing across it. So each resistor, I is equal to V over R, has 1.5 amps. And when we add together all three currents, 3 times 1.5, we see that it totals up to the circuit supply current, which is 4.5 amps there. And that rule works with all parallel circuits. When you add together all of the currents, you always end up with the total current flowing in the circuit. Finally, just to tie it all up, if we do a little bit of transposition formula here, we can make R, the resistance, equal to the voltage divided by the current, okay? And therefore R is equal to 15 divided by 4.5. The total resistance of our circuit is 3.3 ohms. And that is all there is to resistors in parallel. Okay, bye-bye.